Part 2. Can we prevent or even reverse chronic diseases? Practical steps without prescription medication. Dear friends, let us continue with Section 1, Lifestyle and Habit Changes, the Foundational Interventions. Introduction. Small daily habits, profound long-term effects. Chronic diseases rarely develop suddenly. They emerge slowly, often over years or decades, shaped by repeated daily exposures. What we eat, how often we move, when we sleep, how we manage stress, and how closely we align with natural biological rhythms. At the center of many modern chronic conditions lies metabolic dysfunction, particularly repeated glucose spikes and insulin resistance. The encouraging reality is that these processes are highly influenced by lifestyle. This means that meaningful prevention, and sometimes improvement, is possible through practical, non-medicinal changes. Lifestyle interventions have a unique advantage. Unlike medications that typically target a single biochemical pathway, lifestyle changes influence multiple systems simultaneously. Physical activity improves glucose uptake, reduces inflammation, enhances mitochondrial function, and supports hormonal balance. Proper meal timing improves circadian alignment. Quality sleep stabilizes cortisol and appetite hormones. Hydration supports metabolic regulation. Reduced intake of ultra-processed foods lowers glucose spikes and insulin demand. Together, these factors create a metabolic environment that favors insulin sensitivity and long-term health. Importantly, these interventions are accessible. They require awareness, consistency, and gradual habit formation rather than expensive treatments. In many cases, even small changes, such as post-meal movement, earlier dinners, or reducing refined foods, can produce measurable metabolic improvements. This section focuses on these foundational lifestyle strategies, beginning with movement and exercise, followed by food quality, meal timing, hydration, sleep, and stress regulation. Movement and physical activity. The most direct way to improve glucose handling. Skeletal muscle is the body's largest site for glucose disposal. When muscles contract, they use glucose as fuel. This process occurs through both insulin-dependent and insulin-independent mechanisms. During exercise, muscle contraction activates intracellular signaling pathways, including AMP-activated protein kinase, AMPK, which promotes translocation of GLUT4 glucose transporters to the cell membrane. This allows glucose to enter muscle cells even with lower insulin levels. This mechanism explains why physical activity improves glucose control and reduces insulin resistance. Studies consistently show that regular physical activity improves insulin sensitivity, reduces fasting glucose, and lowers risk of type 2 diabetes. Even moderate activity, such as brisk walking, can significantly improve post-meal glucose levels. Importantly, benefits occur even without weight loss, indicating that muscle activity itself improves metabolic function. Sedentary behavior has the opposite effect. Prolonged sitting reduces muscle contraction and lowers glucose uptake. Research has shown that uninterrupted sitting for several hours can impair insulin sensitivity and increase post-meal glucose responses. Breaking sitting time with short movement intervals improves glucose metabolism even when total exercise time remains modest. Thus, both structured exercise and reducing sedentary time are important. Movement does not need to be intense. Frequent low-intensity activity can be metabolically beneficial. Post-meal movement. Targeting the glucose spike directly. Post-meal movement deserves special attention because it addresses glucose elevation at the time it occurs. After eating, carbohydrates are digested into glucose, which enters the bloodstream. Blood glucose typically begins rising within minutes and peaks approximately 45 to 90 minutes after a meal. If a person remains sedentary, glucose disposal depends largely on insulin. However, muscle contraction during this period allows glucose uptake independent of insulin, reducing the spike. Clinical studies show that short bouts of walking after meals significantly reduce postprandial glucose. For example, research comparing post-meal walking with single longer exercise sessions found that 10 to 15 minutes of walking after meals improved glucose control more effectively than one continuous walk of similar total duration performed at another time of day. The reason is timing. Post-meal movement intercepts glucose during absorption. This makes post-meal movement time-efficient, accessible, highly targeted, particularly useful for insulin resistance. Even gentle walking is effective. The goal is not intense exercise, but muscle activation. Practical options: walking inside the house, corridor walking, marching in place, light household work, stair climbing. For weak or elderly individuals, seated calf raises, foot tapping, leg extensions, hand grip exercises, sit-to-stand repetitions. These movements activate muscle contraction and support glucose uptake. Even small activity is better than sitting still. Timing: best, within 15 to 30 minutes after meals. Helpful: up to 60 minutes after meals. Duration: 10 to 15 minutes. This simple habit alone can significantly improve metabolic health. Resistance exercise: increasing the body's glucose storage capacity. Resistance exercise complements walking by increasing muscle mass. Muscle acts as a glucose sink. Larger muscle mass allows greater glucose storage as glycogen, reducing circulating glucose after meals. Resistance training also improves insulin signaling pathways and mitochondrial function. Studies show that resistance exercise improves HbA1c, reduces insulin resistance, and decreases visceral fat. Even low-intensity resistance training provides benefit, especially in older adults. Examples: chair stands, wall push-ups, light weights, resistance bands, squats holding support, hand grip squeezing. Combining resistance training with walking produces additive benefits. Respiratory muscle exercise. Indirect metabolic benefits. Slow diaphragmatic breathing activates the parasympathetic nervous system and reduces sympathetic activity. Chronic stress increases cortisol and adrenaline, which promote glucose release from the liver and worsen insulin resistance. By reducing stress hormone levels, slow breathing indirectly improves metabolic control. Deep breathing also improves sleep quality and emotional regulation. Although its effect is smaller than physical activity, it serves as a supportive intervention, particularly for individuals with limited mobility. Food quality. Reducing rapid glucose absorption. Ultra-processed foods are rapidly digested and produce sharp glucose spikes. These foods typically combine refined flour, sugar, and fats, and lack fiber. Rapid glucose absorption leads to high insulin release. Repeated exposure promotes insulin resistance. Sugary beverages are particularly problematic. Liquid carbohydrates are absorbed quickly and do not produce satiety, leading to larger glucose excursions. Replacing refined foods with whole foods slows digestion. Fiber delays gastric emptying and reduces glucose absorption. Protein and fat further slow carbohydrate entry into the bloodstream. Thus, minimizing ultra-processed foods is a key preventive strategy. Fast food, refined oils, and alcohol. Fast foods combine refined carbohydrates and fats, promoting excessive calorie intake and glucose spikes. Deep-fried foods contribute to visceral fat accumulation, which is closely linked with insulin resistance. Alcohol affects liver metabolism. The liver prioritizes alcohol breakdown, temporarily impairing glucose regulation. Beer and sweet wines also contain carbohydrates that increase glucose levels. Regular alcohol consumption may increase liver fat and worsen insulin resistance. Meal timing. Circadian rhythm and metabolism. Insulin sensitivity follows circadian rhythms. It is generally higher earlier in the day and lower at night. Late-night eating therefore produces higher glucose responses. Eating close to bedtime also disrupts sleep and increases fat storage. Finishing dinner 2 to 3 hours before sleep allows glucose levels to normalize. Frequent snacking keeps insulin elevated. Allowing gaps between meals enables insulin levels to fall and improves metabolic flexibility. Resistant starch. Cooling and reheating carbohydrates. Cooling cooked rice or potatoes causes starch retrogradation, forming resistant starch. Resistant starch is digested more slowly and acts like fiber. It reduces glucose spikes and improves insulin sensitivity. Studies show that reheated rice or potatoes produce lower glucose responses compared with freshly cooked versions. This method is particularly useful in high-carbohydrate diets. Hydration, supporting metabolic stability. Mild dehydration increases vasopressin and cortisol, which may worsen insulin resistance. Adequate hydration supports glucose transport and metabolic function. Drinking water before meals may reduce portion size and slow eating. Older adults should drink regularly rather than waiting for thirst. The order in which foods are eaten can significantly influence glucose spikes and insulin response, even when the total meal remains the same. When carbohydrates are eaten first, such as rice, bread, or potatoes, glucose is absorbed rapidly, leading to a sharp rise in blood sugar and a strong insulin response. However, when fiber-rich foods like green vegetables or salads are eaten first, they form a viscous layer in the stomach and small intestine, slowing gastric emptying and delaying carbohydrate absorption. This leads to a more gradual rise in glucose and a lower insulin demand. Consuming protein and fats next, followed by carbohydrates, further moderates glucose entry into the bloodstream. If sweeter foods or fruits are taken at the end of the meal rather than alone, the already present fiber, protein, and fat slow sugar absorption and reduce spikes. This concept, sometimes called food sequencing or meal order, has been demonstrated in clinical studies showing that eating vegetables and protein before carbohydrates can significantly reduce post-meal glucose and insulin levels compared with eating carbohydrates first. Practically, a simple sequence can be followed. Start with salad or cooked vegetables. Then take protein and fat, dal, eggs, paneer, nuts, etc. Eat carbohydrates like rice or roti next. Take fruits or mild sweets at the end if desired. This strategy is easy to implement, requires no special foods, and is particularly useful in high-carbohydrate diets. Over time, consistently following this order can help flatten glucose spikes, reduce insulin load, and support better metabolic health. Fruits such as watermelon, ripe mango, banana, and jackfruit contain rapidly absorbable carbohydrates, often with relatively low fiber per serving and a soft structure that allows quick digestion. When these fruits are eaten on an empty stomach, there is little to slow gastric emptying, so glucose enters the bloodstream rapidly, producing a sharper rise in blood sugar and a stronger insulin response. This is especially noticeable with fruits like watermelon, which has a high glycemic index, and very ripe mangoes or bananas, where starch has already converted into simpler sugars. Without accompanying fiber, protein, or fat, the body must rely mainly on insulin to manage this sudden glucose load, which can contribute to repeated spikes over time. When the same fruits are eaten after a meal, particularly one containing vegetables, protein, and fat, digestion slows. Fiber forms a gel-like matrix. Protein stimulates early insulin in a controlled way, and fat delays gastric emptying. Together, these effects reduce the speed of sugar absorption and flatten the glucose curve. This does not mean these fruits must be avoided entirely. Rather, they are better taken in smaller portions, preferably after meals, or combined with nuts, seeds, or yogurt. This simple adjustment can significantly reduce glucose spikes while still allowing inclusion of seasonal fruits in the diet. Sleep and stress. Hormonal regulation. Sleep deprivation increases cortisol and reduces insulin sensitivity. Poor sleep also increases appetite for refined carbohydrates. Stress hormones promote glucose release and impair insulin action. Emotional well-being and supportive relationships reduce stress responses. Conclusion. The foundation for metabolic health. These lifestyle interventions form the foundation for preventing insulin resistance and chronic disease. They are practical, accessible, and scientifically supported. When combined, they can significantly improve metabolic health. Understanding the mechanisms behind these habits helps build commitment. When individuals recognize that post-meal movement reduces glucose spikes, that muscle mass improves glucose disposal, that late meals worsen insulin resistance, and that sleep stabilizes hormones, motivation becomes stronger. This section has focused on foundational lifestyle habits. In the next section, we will explore additional practical strategies including food order and meal composition, fiber and protein timing, vinegar and natural approaches, fasting and meal spacing, circadian rhythm and sunlight, and other supportive interventions. The journey continues toward improving metabolic health without reliance on medication. Founder, Holistic Wellness Foundation. IMFAL, Healing Beyond Boundaries.